Your last mastery quiz of the semester is wrapping up all of the previous ones, understanding how they all fit together. They are all functions. You need to memorize how they all fit together. I'll try to squeeze it all in one. Here we go. Linear. Linear is an equation like y equals x, and the graph is a straight line through the origin. Quadratic is an equation like y equals x squared and is a parabola. Again, if we just have y equals x squared, that one has its vertex at the origin. A cubic is the equation y equals x cubed, and this one is our stretched out S shape that has its point of inflection at the origin. Then we talked about the inverses to those two of those. The inverse of the quadratic is the square root. The algebra for that looks like this. And the graph looks like the quadratic on its side. Except to make it a function, we only look at the top half. The cube root looks like that as the algebra. And it too is a rotation of the cubic, or a reflection of the cubic graph. So it looks like it got flipped on its side. This one you can see the whole thing because it's still a function even when it's reflected. Notice that both the cubic and the cube root are constantly increasing graphs. They increase over the whole set of it. Square root is also an increasing graph, and so is linear. The quadratic decreases and then increases. That should help you recognize the difference. Then we had a couple odd ones. We had the step function, which we chose to do the floor function, the floor of x, the greatest integer less than or equal to x, which meant that it had an open circle on the right end. Okay. Make sure that your steps don't overlap because that would make it not a function anymore. And we had the absolute graph. Absolute value is written like this, and it means that we want to know the distance between any point and 0. Since distance is always positive, the answer to that is always positive, and the graph looks like a straight V shape. That's 8. We have 2 more. Those 2 are also inverses of each other. They are the exponential graph, which we put in our equation as 2, or in our books as 2 to the x. The exponential graph increases exponentially, right? And then we had the logarithmic graph, which, to make it a perfect inverse of that one, we did as y equals log base 2 of x, since this is base 2. The logarithmic graph also increases, but lots slower than the exponential graph. And the logarithmic graph and the exponential graphs are also inverses. So you can see them as reflections over each other. Let me draw it over here because I think that's how I can remember. The exponential graph does this. Here's the line of reflection, the y equals x. And when I reflect it, I get something that looks like that. That's how I remember the logarithmic graph. I hope that helps you. This is another one that will help greatly from flashcards. You need to know the equation as well as the name and the picture. So make yourself some flashcards and keep practicing.